We shall start the session. My name is Sian, and it's my pleasure to be the moderator for the webinar today. Welcome to the webinar on how to conduct an effective risk assessment hosted by Synergen OG. And we have our program speakers today, which is Puvan and Wijun. We will also welcome questions and comments throughout the session via the Q&A pane that you can find from the Microsoft Teams windows. So please do list down your questions at the pane, and all the questions will be attended towards the end of this seminar. With that, I'd like to hand over this to our first session presenter, Puvan.
Good morning, everyone, and welcome to our webinar on how to conduct an effective risk assessment. We hope at the end of this session, you will have better confidence and better understanding on how to conduct an effective risk assessment. And at the same time, at the end of our session, you will have a lot of questions to ask us, which hopefully myself and my colleague, Wei Jun, will be able to answer them live during this session. The objectives for today's webinar is very much on to understand what makes up an effective risk assessment. We will go through a series of steps in order to actually facilitate that process and how do you actually undertake a risk assessment effectively. We will then also look at our experiences, and we will share some of our experience about risk assessments, things that we have noticed as facilitators of risk assessments. And we will share some of the common root causes of poor risk assessments and some of the issues that you may want to actually take note of, so that if you are actually facilitating a risk assessment or participating in a risk assessment, you will actually be able to actually undertake those risk assessments more effectively. We will also go through some examples on how risk assessments could have avoided industrial major accident hazards, and also look at further Q&As from yourselves. A little bit about Synergen OG. We're very much a consulting company. We are an agile and highly responsive engineering consultancy with offices in Southeast Asia and also in the UK. We're very much specialized in the arena of technical risk, process safety, and also loss prevention, including operational safety and also training and workshop facilitation. A little bit about the co-founders and also the presenters. I'll start off with myself. My name is Puvan Balasubramaniam. Have about more than 24 years experience now working predominantly in Asia and also in the North Sea, mainly in the UK. I am a professional process safety engineer with the ICAMI, certified bowtie trainer, and also a certified audit XP and incident XP trainer. Have a lot of experience working in the North Sea, having a lot of experience doing safety cases, and my experience in safety cases also has been extended into Brunei and also within the region in Southeast Asia. Used to work with DNV previously, and then from that on moved on to operations and worked with Talisman Energy, which is now Repsol, and Premier Oil in the UK, before co-founding Synergen with my colleague, Dr. Keith Bell. Keith is a very experienced facilitator, a very experienced HAZOP and SIL facilitator, also a certified bowtie trainer, and he is a consequence modeling, and FSA specialist. Our other presenter today is Mr. Tong Wei Jun, who is a principal safety and risk engineer at Synergen OG. He has more than 15 years working experience, very highly competent, very highly technical. I have the pleasure of working with him on a lot of projects. He is also a certified bowtie XP practitioner and also a TUV certified SIL facilitator, very experienced in PSM and risk assessment training, and has undertaken a lot of facilitation workshops for various companies throughout the region. Okay. A little bit about the types of activities we do, and one of the reasons why we are presenting this webinar, because we actually do a lot of workshop facilitations, especially in HAZOPs, SIL workshops, and also mainly on risk assessments as well. Okay. On that note, I will pass it on to Vijun, who will actually be presenting the 4-step process on how to actually undertake an effective risk assessment. Over to you, Vijun.
All right, thank you very much, Puvan. I hope everyone can hear me. All right, so I'll dive straight into it, presentation on what is an effective risk assessment. So risk assessment basically comprises the following 4 stages, mainly the identify, assess, control, and review. This standard process is widely used throughout all industries and is relevant for all work activities. We will be exploring what each of these steps involves in greater detail, but at this point, I would just like to highlight that all of these steps forms a cycle. So this means that the risk assessment process is never a static one-off activity, but should be carried out throughout the project life cycle. Just a bit about the applicable regulations that we have within Brunei, especially we have specific regulations, especially on workplace health and safety, governing how often and when risk assessments are conducted. But of course, many other countries are also seeing the benefits of such regulation and are looking to follow suit. So let's go straight into the first step of risk assessment, which is the identify stage. This involves understanding what our hazards are and who can be harmed by them. We can visualize this stage as understanding the background of the hazard. So before we get started with identifying what our hazards are, we should first understand what are hazards. So hazards are defined as any source of potential damage, harm, or adverse health effects on people, environment, or property. So it really refers to an activity or a state. Most of the time, hazards may be either dormant or potential hazards. Here we can see some examples of what we mean by hazards. So we have things like overloaded sockets, cracked windshields, wet floors, and even snakes can be a hazard. Moving on from that, we talk about now risk and also the interrelation between hazard and risk. When hazards and the potential of it happening interact, this results in the realization of an active hazard. So this interaction between a hazard and the likelihood, otherwise known as risk, is a key concept that I'll be exploring later on in this webinar, so stay tuned for that. So for example, if you look at this on this screen, we see that, for example, taking the scenario of the overloaded socket. This becomes an active hazard when someone touches it, exposing themselves to the risk of electrocution. And similarly for the other examples that we have. There are really 2 main types of hazards, namely the process hazards and also the occupational hazards. So when we look at process hazards, we are looking at dealing with hazard events that have the potential to release hazardous materials and energy. So we're really focusing on things that can lead to loss of life, injuries. So looking at your major events, damage to asset and environment. But on the other hand, we have occupational hazards, which mainly involve safety and welfare of people engaged in the work. So you'll find that these kind of hazards are very much individual-centric. So things like your typical slips, trips, and falls. All right, and on our next slide, we have just a few pictures that try to illustrate the differences between process hazards and occupational hazards. So on the left-hand side, you can see that we have things like fires and explosions. You have things that can lead to wide-scale power outages, toxic gas releases, oil spills into the sea. Whereas on the right-hand side, for occupational hazards, you have things like trips, falling from height, getting stuck in confined space, mechanical tools, accidents. So I think it's pretty much very intuitive what are the differences between process hazard and also occupational hazards. Broadly speaking, for hazards, there are also 5 different categories that we can have. We have, first of all, physical hazards, which things are things that are capable of causing physical harm to people or objects, without necessarily touching it. So these are things like extreme heat, excessive noise, poor lighting. These are all examples of physical hazards. Next, we also have ergonomic hazards. This is looking at the type of work that you do, body positioning, working conditions that put a strain on your body. So for example, things like repetitive motion, poor workstation setup, these are all examples of ergonomic hazards. And then we come to chemical hazards. So these are hazardous substances that can result in both health and physical impacts, such as skin and respiratory irritation, blindness, corrosion, and also explosions. What we have is biological hazards. This is something that I think is very pertinent in the world that we are living in now. This includes things like viruses, bacteria, insects, and animals, anything that can cause an adverse health impact as biological in nature. Finally, we have psychosocial hazards. These are the result of adverse impact on mental health or well-being, especially now that we are being locked down a lot in many countries. So this is quite pertinent. So things like sexual harassment also falls under this category: victimization, stress, and also workplace violence.
Vijun, I think I also might want to add to the audience really is that this is probably the first step is also the most important step, because we can't really move on to the rest of the remaining steps. And we can't really manage and control our hazards if we don't really systematically and comprehensively identify your hazards. So really something for the audience and people attending and listening to this webinar is you really need to go through and try to clearly identify all your hazards relating to the scope of work that you're actually looking into. Otherwise, you will actually have an incomplete risk assessment.
Correct. Thanks, Puvan. So I think that really comes down to the point of what I was saying, like the first step is all about understanding your risk. I mean, you're understanding your hazards. So getting to know your hazards. So it's the first step, and it's probably the most important. Right?
I guess the categories are very good as well, what you're mentioning, because if you define categories correctly, then it gives you a more structured platform for you to look into towards identifying hazards quite clearly. Because otherwise, then if you're just trying to brainstorm without any categorization or any aid, you might actually be in a position where you might forget about certain things.
Yes, it also puts you in the right frame of mind. So when you think about different categories, you approach it from a different way.
Correct. So I guess as facilitators, we always do a lot of preparation in advance, and we always look at part of our preparation is to make that categorization and have that structure in place so that when we actually do that risk assessment, we are prompting also the attendees in order to make sure that they are thinking about the issues. Yeah. Okay.
Correct. Okay. Thanks, Puvan.
No problem.
Right. So moving on to the next one. So now we move on to step number 2, which is assessing our risk. So in this stage, we're diving deeper into what the hazard is. Where we're looking to assign risk level to the hazard, and also to have at least some means of measuring and benchmarking the risk. So here we will need to think about questions such as, what is the extent of the damage, or how many can be hurt by this hazard? What are the root causes? How likely is this event to happen? So now you can see that we are exploring in greater detail about what the hazard is and basically what can happen from the hazard. So earlier on, we have touched briefly on the concept of risk. Effectively, at its most basic level, risk is a way of measuring the hazard as a combination of 2 elements, namely severity and probability. So a hazard with high risk could involve an event with high severity, high probability, or even both high severity and probability. So this is something that you probably want to keep in mind. So severity, what do we mean when we talk about severity? So severity is really defined as the magnitude of the hazard consequence, or in other words, very simply, is how bad can it be? So this is defined in kind of quantified amounts, such as what is the cost of repairs, number of casualties or injuries, how much compensation do you need to pay out, what is the loss of production cost. So on the other hand, probability is the likelihood of the occurrence, or put more simply is what are the chances of this happening. So you can see that both of these are kind of the two elements of risk. So clear understanding of severity and likelihood of any hazard is really fundamental to any risk assessment. The importance of this really cannot be understated, because I think a useful phrase that we always come back to, we always introduce to our clients and also our audience when we do our workshop facilitation is you can't properly manage risks if you don't even know what they are.
That's very true, Vijay. So it comes back to really, and to the audience as well, that you want to actually be very, very, very taking out to great cognizance of the fact that you actually have to get step one done correctly in order to actually then manage your risk. Yep.
Correct. All right, then here I would just like to summarize 3 similar but related concepts that we have really introduced so far. The first, of course, is a hazard, which is defined as something that has the potential to harm you. So the example given in this slide is sharks swimming in the sea will be classed as a hazard. So in this example, important thing to note is that sharks will still be a hazard, although the person is not in the water at the same time together with the sharks. So this really represents the concept of dormant or potential hazard. The next concept, of course, will be that of risk. So this one involves the hazard coinciding with the likelihood of the event occurring. So as we mentioned in the previous slide, risk involves both the elements of severity and also probability. So in the situation that here is that swimming in the sea, we are exposed to the risk of being bitten by a shark. So whereby now we see that both the severity and likelihood are both present at the same time. And then finally, the concept is to keep in mind is that of consequence or severity. So this is really the ultimate undesired result or effect due to the hazard. So this really describes how bad can the outcome of the hazard be. So in this example, the consequence, of course, of this scenario would be possibly having your foot being bitten off by a shark. So I hope this simple example helps you to kind of differentiate what do we mean by the differences between these 3 terms of hazard, risk, and consequence, because we do still see quite a lot of confusion between these three terms. Just to keep in mind the concept of also major accident hazards, which are low probability but high consequence accidents. We'll be exploring this topic shortly, but just want to want you to bear in mind that major accident events are these type of incidents which are low probability but high consequence. And just a final point to bear in mind is that just because the incident is low probability, this does not equate to no probability. Okay, I'll go on to the next one. Okay, so now that we understand the fundamental concepts, we can now look at risk assessments. So broadly speaking, risk assessments are a systematic process of identifying hazards and evaluating any associated risks. So risk assessments really are just a generic term for tools and techniques used for assessing risk. So there are many techniques that are available to us. So some common techniques that you may have come across are things like failure modes and effects analysis, bow tie diagrams, HAZOPs, hazards, layer of protection analysis, fault trees, and also event trees. But I mean, regardless of the method, risk assessments typically involve assigning some form of measurement of the risk to the hazard. So this really involves fundamentally deciding how likely is it that someone could be harmed, which is the likelihood, and how serious it could be, which is the consequence element. One of the most commonly used tools for this is applying a risk matrix. So a risk matrix really shows the interaction between 2 components of risk, which is the likelihood and consequence. Typically, what you'll find is that risk matrix are generally company specific or industry specific, because each industry has slightly different permutations of what consequence and likelihood is applicable for that particular industry. Here, I'll just show you what is how a typical risk matrix looks like, which can be used in a risk assessment. So what you see in this example, this is arranged in a 5x5 grid, where we have consequences on the y-axis on this side, and we have likelihood moving on the x-axis. So note that the risk outcomes are typically color coordinated. So in this example, we have our low risk region on this portion, and then we move up to medium risk, medium high, and also our high risk zone. So while referring to the risk matrix, what the risk assessment team will do is normally assign a suitable likelihood and also consequence category for each of the hazards considered, and obtain a corresponding risk level. So for example, just to illustrate this point, for a given hazard, we may define our likelihood to be 4 and our consequence to be 3. So by referring to the risk matrix, we can see that this will produce a risk level of 12, which lands us within the medium-high risk zone. Like so. Okay, so you see that this results in a 12. All right, so, but you may be asking, how do we define the consequence and likelihood? So generally, risk matrices also come with guidance on what each level corresponds to. So on this slide, I'm just showing you an example that's based on Brunei China industry guidance in terms of event likelihood and also consequence towards people. So in this example, for example, assuming that we define our hazard having the potential to cause fatality, we would assign it to have a consequence level of 5. So you can see that this is just a guide to help us to define our consequence and likelihood levels. Okay, then now we move on to major accident hazards. So risk assessments are really a useful tool really for pinpointing major accident hazards, which is a term which normally is being used within the high hazard industries, such as petrochemical and processing. So really what we want to say is that not all hazards are created equal. So major accident hazards are really hazards with the potential to result in severe or catastrophic consequences to people, assets, environment, or even your reputation. But the exact definition of what incidents constitute a major accident hazard would also still depend greatly upon the nature of the facility, your operations, your process, and also the company itself. Here is just some general guidelines on what constitutes major accident hazards based on the Brunei COMA regulations. So typically you're looking at things like your loss of containment, your fires and explosions. You're looking at major events that can cause structure damage, loss of stability, and also, of course, anything that can result in death or even injury to 5 or more people.
I think I would also like to add that the Brunei COMA regulation is a very sound regulations, and it's taking the lead in very much in Southeast Asia. Of course, Singapore now also has the COMA regulations, the equivalent safety case regulations, and the major accident hazard definition. It's very similar in various other countries who've also adopted similar regulations and also safety case requirements, where the focus is about managing major accident hazards.
Yeah, that's true. So I think you see that if you allow yourself to focus upon the major accident hazards, you really focus yourself on preventing the big events that can really hit the headlines, that can really cause your major consequences.
That's correct. That's what you mentioned before, Wijun. It's the low probability but high consequence event.
All right. And here are just some typical MAH categories that are applicable within the petrochemical and processing industry. But like I mentioned before, the exact MAH that you have would very much depend on your facility and the nature of your operations as well. But these are just some typical examples. Okay, moving on to step number 3. So now we are moving on to the control stage. So now that we have a good baseline understanding of hazards and its potential impacts, now we can look at how do we implement risk reduction barriers or prevent or perform modifications to reduce the risk? So here we're really looking at, can the causes be eliminated? How do we stop this hazard event from occurring? So these are things that we need to keep in mind. So it should be clear by now that all activities really pose some form of risk. A common example, of course, would be our day-to-day work. So whether we're working in an office or an offshore oil and gas platform or a chemical plant, really all work involves some varying degrees of risk. So remember always, the risk equals the severity multiplied by probability. So of course, one way we can think of, one very easy way of eliminating risk is avoid going to work altogether. But of course, if everyone were to stop work, it's not really a feasible approach, because this would really lead to, of course, a loss of income and a halt to all of our industries. So it's not really a feasible solution on that point. So therefore, as long as we have our necessary daily activities, some form of hazards, risk can really never be eliminated completely. However, what we can do is find some balance between the risks and also the benefits associated with the activities being carried out. So this concept of balancing both the risks and the rewards is really otherwise known as risk tolerability. So applying risk controls really involves something that we call barrier thinking. So what does barrier thinking mean? It involves placing risk controls or barriers which can stop the progression of the hazard event. So all facilities typically include multiple protective systems, otherwise known as layers of protection. These are just some very general examples. Of course, the specific barriers that you have might be different. These are just very basic categories. So what I want to highlight here is that if all measures function perfectly, basically the hazards would never occur. This was better visualized using this Swiss cheese model. So this is a very well-known model, which is based upon the idea that potential hazard has a very specific event progression track before it results in a hazardous event consequence. So you have the potential event hazard here, and you have the hazardous event. So you have a specific trajectory that goes through for it to become a hazardous event. So to prevent the hazardous event outcome, what we do is we place layers of protection. So these are your risk barriers. So we place layers in between the hazard and also the hazard event. So here what we see is that in an ideal situation, each barrier performing its role will be able to prevent the hazard from resulting in the hazard event consequence. However, of course, in reality, we know that nothing is perfect. Each barrier there can be weaknesses or holes in each barrier. And of course, if these holes all line up, these could lead to a hazard having a path to resulting in the hazardous event. So you can have like if you see it on this slide, you have the line going straight through from the hazard all the way to the hazardous event. So therefore, we can see that no matter if we have multiple barriers, the integrity of each barrier is also very vital to ensuring the hazardous event does not occur. So understanding the control measures allows us to plan and respond accordingly. Generally speaking, control measures really fall into two types. You have your event prevention types categories and also your consequence mitigation category. So in terms of event prevention, we are really focused on the use of pre-event controls to reduce the likelihood of failure. So within event prevention, we have two subtypes, which is elimination. So this is really removing the hazard altogether. So an example is conducting periodic inspection, ensures your machinery is always in good, proper working condition. The other subtype is prevention. So this involves stopping the hazard event from occurring. So an example of this is proper design pressure design to prevent the likelihood of overpressure. So this is an example of prevention. But on the other side, we have consequence mitigation. So these are measures which are post-event controls to mitigate and minimize the consequences. So within consequence mitigation, we really have three subtypes. So we have the control subtype, which is measures which are aimed at preventing the hazardous event from escalating into a major event. So an example here that we can give is putting a bund around a specific tank so you can contain or limit the amount of the liquid that's being spilled out. The next subcategory we have is mitigation. So these are measures meant to minimize the impact or the size of the hazard consequence. So an example of this would be a depressurization system. So you depressurize your system, you're releasing the inventory to a safe location without it being released as a loss of containment. And finally, we have recovery. So these are measures to assist in returning the hazard situation back to normal. So a good example of this, of course, would be things like your medical facilities.
I think also you may want to remember as well that these are just some examples of categorization of your event prevention and consequence mitigation. For various different clients that we've seen, they also have added in substitution as an event progression rather than just elimination prevention, where you are replacing high hazardous materials which are maybe toxic to something that is less toxic, if possible, for the processing facility. And also things like for the consequence mitigation, you're looking at detection, also taking that into account as part of the event progression and other means, right? And I guess this is very important when you're looking at control measures. You want to think of it from the Swiss cheese model. The more barriers, the better it is. And also for people who are familiar with the bow tie method, you can actually visualize this better by looking at the bow tie method. But the key is to have, like what Bijun was saying, look at event prevention and also consequence mitigation. Yep. And that I think is the key. Yes,
correct. I mean, just another point to add on to that is that it's not only just about the number of barriers that you place, because like you said, on the Swiss cheese model, actually the number of barriers is not just the sole determinant. Like you also have to look at the integrity or the quality of your barriers as well.
So, absolutely, Vijay. So eventually, identifying the barriers alone is not good enough. It's about maintaining those barriers also is just as important. Hence why asset integrity is becoming more prominent in the energy industry, especially where you're looking at making sure that the barriers that you have in place are effective in order to actually prevent that event progression from becoming a reality and a consequence situation.
Yep.
Right. I think one important thing also you want to really remember is the increasing effectiveness. Obviously, the event prevention is more effective than the consequence mitigation, right? If, for example, preventing loss of containment event is obviously a lot better than trying to actually control and fighting the fire once it's become a consequence. So just something you want to actually take note of when you're doing risk assessment, to try to actually look for more of the event prevention measures so that you actually look at things that become more effective in order to manage those hazards effectively.
Yeah, I think in the past a lot of the focus has been more on the mitigation side of things, whereas I think now in the more modern thinking is maybe more shifting towards event prevention, like what can we do differently. So it's looking more from all the way back to like a design standpoint, like how can we design things to be safer, or inherent safety is a very key word.
Absolutely, and I think it's a very good point that what Bijun was saying. Inherent safety is something you want to actually take into cognizance of early on in the design of a project, so that you're actually looking at things like elimination, substitution, and prevention early on before you start looking at the event progression and the consequence mitigation. You're absolutely correct, Bijun. We're noticing that with a lot of clients where things are changing now, the emphasis towards the event prevention rather than consequence mitigation.
Correct. Okay. All right, then now I come to stage number 4, which is really the review stage. So in this stage, we're evaluating the performance of the risk controls. So we're looking at things like, are some controls performing better than others? Also, we need to consider how our risks may have changed. Is there any new information that's come up? Are there any new hazards? So all these kind of things would fall in place within this stage. So the review stage is I think like any other stage is also of equal importance, since in any facility, things never stay the same all the time. So without regular monitoring or review, we may not realize that our risk assessments are no longer valid. So this stage is very important, since this is where the effectiveness of the process can be demonstrated. So conducting a review periodically is very similar with going to your doctor, getting your routine medical checkup. Because even when there's no overt signs of any illness, some life-threatening conditions may still be developing that really should be addressed proactively before it kind of reaches a very severe state. So there are really three aspects that which we want to cover in the review stage. First of all, being the performance. So this is where we review and look at key indicators to judge how well we have identified and implemented suitable controls for our hazards. Then we have any changes in scope. So this will be looking at what are the changes to our facility, our personnel, and also our operations. But I mean, these are just some examples. That there are many other changes in scope that, of course, can affect your risk assessment. And also, of course, finally, your knowledge and experience to make sure that our assessment also accounts for lessons learned, improvements in the industry, and also in technology. So this review process really requires reflecting upon the following questions. So for example, the first one is, has there been any significant changes? So looking at our things like our facility, has there been any changes to the process? To our people, so has there been changes in our organization chart? Have there been people who have been transferred to different departments, or maybe some people have recently resigned or been moved to a different role? And also to our operations as a whole, have there been changes to any of our operating procedures, our activities, our frequency of certain tasks? The next is, of course, is there any problem areas identified? So we're looking at really things like, is there any high potential leak areas that maybe has been noticed by your team? Maybe any frequent system trips? So these are all examples of problems that might be identified. Then we have also looking at, are my current controls still effective? So here we can review the performance data of our controls. Are they still effective? Are they still meeting the targets and goals that we set up for them? Then we also have lessons learned. So this really covers both on-site lessons learned, so things that maybe have been learned among the team within the site, and also among the industry as a whole. And there are also any new developments which can be implemented. So this is really looking at new technologies, new systems. As you know, in the digital age, many new technologies are always coming up at a very, very fast pace. So things always change. So it's very important not to always stay static. And finally, has my risk profile changed? Has anything which can affect the scope of my risk assessment? So it's always good to go back to the scope of the risk assessment that was conducted. So usually when you conduct risk assessment, it's always based on a certain scope or boundary. So has that boundary changed? Has my plant gotten bigger? Have there been more people now been assigned to the plant? So things like that. So have my risk profile changed, or is also my risk assessment up to date? So if a risk assessment was done 10 years ago, is it still valid now? So these are the things that we should always keep in our mind.
I think Vijun as well, and also to the audience, always have to actually bear in mind that statement that things will always stay the same. So you always want to take cognizance. And these are just some questions that for you to think about when you're looking whether you really need to reassess or revalidate your risk assessment. There is no really hard, fast rule of when you need to do this. You may need to do it every 6 months. You may need to do it every year. You may need to do it only after every 3 or 5 years. But that depends on really the changes in that risk assessment that was done previously. So there is no really fixed duration on when you need to do this, except obviously if there are regulations that require you to do this very as every 5 years, for example, within the Brunei Coma regulations or in the UK regulations, then there is a specified frequency. But beyond that, I think everyone should really take cognizance of the fact that your risk assessment may be invalidated because of things that have changed. So you have to bear in mind that these things, you'll have to want to actually look into what are the changes that will affect the outcome and the output coming out from your risk assessment. So therefore, then you will actually have to review your risk assessment and probably revalidate the risk assessment again.
That's right. Thanks, Bhuvan. I think that's a great point, because some people always tend to think about like risk assessment review in terms of like a fixed interval. Like, so, oh, I've done my risk assessment last year, so I'm not due to do it for the next year. So, but I mean, things always change, so it should really be a case-by-case basis. So everybody, you know your facility the best, you know how things have changed, so you are really in the best position to judge, do I need to update my risk assessment or review my risk assessment? Okay. So yeah, this is just coming on to the point of the requirement to revisit the risk assessment. So this requirement is also stipulated as part of the Brunei WSHO regulations that requires you to keep the records for a period of not less than 3 years. So just to wrap up what I've been talking about so far on the 4 steps. So first of all, we have the identify stage, which is ultimately about understanding the background of the hazard, getting familiarized with the hazard itself. Then we move on to the assess stage, which is we're going to a deeper understanding of the hazard. And we're looking at, if you remember, to define the likelihood and the consequence, and also ultimately the risk level. And then we have the control stage. This is where, like I said, we implement barriers to reduce the risk level. We talked about things like the Swiss cheese model, barrier selection, and so how effective your barriers are. And then finally, we have the review stage, where we talked about evaluating the performance of your risk controls, and then consider any improvements or changes in scope. So just want to leave you with this final point, is that risk assessment really is a continuous process. That's why this diagram is shaped like a circle. So it always is a cycle. So after you've done with your review, then you should move on again into your identify stage. So looking back in, is there any new hazards that's been coming up? So then the cycle again repeats itself. Okay. Yeah, so I think I'll pass it over to Bhuvan then to continue with the next section.
Sure, thank you, Regent. If you want to go to the next slide, and I think what is showing just in 2020 already is that we are still seeing a lot of major accident hazards and major accident incidents within the industry. In 2020 alone, we've just taken out a sample and we've identified about 4 different major accident hazards or incidents rather within the industry. And what is showing is that because of the global pandemic as well, there has been a lot of factors in terms of there's a reduced inspection and maintenance being carried out. There is a lot of impact onto manpower requirements because it's not so easy to actually get your technical specialists in, or people that you really need to actually facilitate your plant operations at the right time due to restrictions being in place. And risk assessments also then come into play about how it's really being done. So we have found some common root causes about poor risk assessments, which we'll share in the next slide. And really a lot of the problems that we have noticed as well, and this is also coming from review of these incidents that we have actually mentioned before, is there's been a lot of poor understanding of what is hazards and risks, and how does that really impact onto people working in the plant and also the general population, and especially for onshore facilities. So this is something that a lot of the risk assessments need to really be focusing on, so that it's actually, like what we mentioned earlier, it has to be comprehensive and it has to be looking at all aspects thoroughly and as well as you can, based on the participation of people involved. And we'll talk about some of those things also later on. Also things about improper storage location was what we looked at. It was too close to populated areas. There was a lot about incompatible chemicals. So this kind of like fed into our view that there was no proper risk assessment being carried out for those particular facilities, hence resulted in the major accident incidents. Things like not following standard operating procedures. There was no unsafe handling or storage of the materials. There was lack of skilled personnel on site, and then mismanagement and lack of monitoring. I think a lot of people working in the industry will see these are common problems that we always see from an operations point of view. So more vigilance is actually required in order to manage your hazards effectively, so that you really prevent the major accident incidents from occurring. I think, Vijay, I think something we want to share to everyone is kind of like some of the risk assessment techniques and also some issues that we've identified, right? I mean, we have that in the next slide, don't we?
Yep.
How risk assessment can have made a difference for this incident and also for any risk assessment for that matter. You want to actually looking back at the 4 steps. You want to really make sure that your identify is very comprehensive. You have to understand what the hazardous materials are like, how it can be used, how it can be stored safely. So like we mentioned earlier, looking at a very structured way of actually categorizing your hazards so that you can actually look into the hazards comprehensively is key in order to actually undertake an effective risk assessment. Assessing as well, you want to actually make sure the risk level for the process and plan accordingly. And you have to also make sure that all stakeholders also understand what that risk is. And especially for onshore facilities, then you have the general public that needs to be informed as well, because the surrounding population could be located close to the facility. So therefore, as duty holders, the onus is on yourselves to actually communicate the risks and the potential consequences that potentially can actually affect the general public. And we've noticed that, if you look back at incident investigation reports, you will find that there were a lot of lessons learned coming towards that. Control, dedicated storage areas, secure tents, handling procedures, and plant site location are obviously key. So if you have really done a proper risk assessment, this could have actually played a part in actually making sure right control measures are in place. And more so if you have done it during design, but also you can do it during operations. And then at review, you want to continuously monitor the site and respond to any changes. A very good example we included here is worker shortage due to COVID. Are we looking at replacements? Are we looking at operations need to be modified to reduce the risk? So these are the type of situations that you may want to consider when you're doing risk assessments going forward, given the current situation globally. Some shortcomings that we have noticed in risk assessments are, if you really want to do an effective risk assessment, you need to actually have the right level of participation in that risk assessment. You need to have various different discipline people and people from different departments, for example, or also people from different stakeholders that need to be involved in that whole process in order to undertake a very effective risk assessment. That's very important, really. Next is also you actually have to have the right level of information available for that risk assessment to be conducted properly and thoroughly. For example, you need to have the right kind of procedures, and the procedures have to be up to date. The PNIDs have to be current. As you can see, if you don't have the right level of PNIDs or the up-to-date PNIDs or the right level of documentations or up-to-date documentations, you're effectively working on something that is older, then you're not really looking at an effective risk assessment. You may be missing out things. And we've noticed sometimes where we have been doing some workshops where the procedures or those documentations being supplied to us are not current. So we'll have to actually stop that, make sure the right documentation and those documentations are updated and current, and only then undertake that risk assessment. Another one, I'm sure Vijun also, I mean, we as consultants, we notice this is, there's a lot of pressure about time. Everyone wants us to do a risk assessment in a day, but sometimes it takes more than a day. So planning and making sure sufficient time is allocated to people is very, very important in order so that you can actually comprehensively perform the risk assessment. Yeah. And lastly, the scope is not clearly defined. We've had experiences going into a risk assessment workshop where what was mentioned in the terms of reference and what was mentioned beforehand was different to what was actually the expectations were at the workshops. So it's very important to clearly define the scope that actually you want to be looking at when you're actually undertaking your risk assessment. Good. I think we're going on a bit longer than we expected already, Bijun. So maybe we should look at any questions from our audience.
Right. Thank you, Proven and Regent, for an insightful presentation. So without further ado, we shall now proceed with the Q&A session. So the first question that we have is related to external hazards. So hazards such as environmental extremes, are they considered under the list of 5 typical hazard categories?
I think I can answer that one. Shall I take that one, Bijun?
Yeah, go ahead.
I mean, the slide what we showed you was just typical type of hazard categories, and obviously external hazards also should be included. Normally, when we do a risk assessment, we will look at hazards posed by the facility itself, if you're looking at the facility, and also external hazards such as environmental extreme. For sure, you will have to actually look at that as well. A good guide in order to identify categories of hazard is looking at the ISO 17776, which actually has a very good set of guide words for the processing industries. And we tend to adopt that ourselves because it's a very good aid in order to actually give you prompts of categories and typical hazards that you may want to actually consider when you're undertaking the risk assessment.
Yeah, I think the thing to highlight is that just categories are just a way to help you to think about the hazards. It's not really such a really like a thing that you really need to always implement. So I mean, categories can be amended according to your particular industry, right? So
absolutely. It's not an exhaustive list. It's just an aid, and even the ISO 17776, as I mentioned, is just an aid to give you a set of guide words, but it's not exhaustive. For your particular risk assessment, you may find there are other hazards that you may want to include in that risk assessment. So part of that process of doing the risk assessment is you do the risk assessment as a team, so that you're actually drawing upon the experience from all the different stakeholders involved in that process, and therefore everyone has an opinion about different type of hazards that may be present for that risk assessment and the scope that you're looking at.
Okay, so the next question that we have is, what would be the best way to ensure that all the hazards are identified accordingly, to ensure that none of the hazards has been neglected?
Do you want to take that one, Vijay, or you want me to do that?
What is the best way to ensure that all the hazards are identified accordingly? I think using like what you mentioned about the ISO 17776 is a good way because it's quite a comprehensive list of guide words. So it helps you to ensure that nothing could be missed out. But of course, that's why I said it depends also on the level of participation also. Like you need to get the right people involved to make sure that they understand the scope, and that's when really you can identify all the hazards that's applicable.
I think I also can add that you need to also have a good facilitator that is always prompting the risk assessment team to be asking by asking a lot more questions. So you always have to be prompting people to think about what other hazards there may be that potentially could occur. And that's very important, really. You need to have a good facilitator that's prompting discussions and a team that has the right level of experience and the right level of different disciplines so that you can comprehensively look at all the various type of hazards that potentially could occur.
Okay, the next question that we have is that Regulation 5 has stated that impose a duty to record and keep records of the risk assessment for a period of not less than 3 years. So the question is, which industry is this actually pertaining to?
I believe this pertains to all industries that actually poses risk to people.
Yeah, I think it's all industries that falls under the governance of this WSH regulation within Brunei, which I guess is all industries operating within Brunei.
Correct. I mean, this is the Safety and Health Act, and it applies to every industry.
Okay, the next question that we have is, there's a mention regarding to no up-to-date documentations. And the question is, to what extent of changes shall that prompt a reassessment?
Okay, that's an interesting question. I guess we give some examples of type of questions you want to ask, whether some examples could be you've done modifications, you've actually changed your manning levels, your performance has changed, maybe there's new introduction of new technology, and there are actually no rules to when you actually have to update a risk assessment. I mean, the regulations tell you actually have to keep records, but really you should be keeping your risk assessment as current as possible. So whenever there's a change, you actually have to go through a internal process of asking yourself the questions, has those changes that has occurred, have they really, would they really change the risk assessment outcomes? So this is a question that you'll have to ask yourself internally before making that decision. You can use some of these pointers that were put in as part of that aid in order to actually derive or decide that need or whether you need to update the risk assessment.
I'll just add something. I mean, I think this is quite an interesting point, because I think this is something that really should be captured as part of the company's management of change process. So normally when you have some kind of change, you need to go through that kind of decision process. Is this a change that warrants relooking at the risk assessment? So that's when all these pointers that we've given you, all these tips can come into play.
That's a very good point, Vijun. Thank you for reminding me. So the management of change is actually a good way of actually trying to capture whether a change is significant enough to actually warrant the risk assessment to be updated. And bear in mind, management of change is not really management of change to equipment. It can be management of change to people. Your organization may change, which may also require your risk assessment to be reevaluated.
Okay, I guess we'll take the last question. This is regarding reviewing existing refinery facility. So there's a statement or there's an opinion which states that it's easier to review a new projects rather than existing facility. So what's your view regarding reviewing existing refinery facility to reduce risk?
I guess the question is looking at how often do you need to do your risk assessment for refining facility?
I think the question is really more about it's kind of maybe easier to do a review on a new project rather than a plant that's been operating for some time, because maybe there's some information that's been lost along the way or things have changed so much. So the scope is not really so clear cut anymore. I think that's what the question is.
So that is true. I mean, you will always have those challenges for older facilities because of lack of information. And because you've lost a lot of the documentation, especially if it's a much older facility, then a lot of the documentation would have been just paper-based. And if you didn't really record or kept it properly, you would actually have, you easily could find yourself in a position of not having those documentation available. Yes, I think a lot of operators these days are looking at revalidating their risk assessment, like doing a HAZOP every 5 years, so that they can keep it up to date.
Okay, thanks, Poovan and Vijun. I guess due to time constraint, we have now come to an end of the webinar. So ladies and gentlemen, once again, thank you very much for your participation in this webinar, and I hope you enjoy the session. So as shown on the screen, here's a list of our available courses. And if you are interested in any of these courses or services that we can provide, please do not hesitate to email us at admin@synergenog.com. And for any other questions that we are unable to attend or to respond accordingly today, we will revert to you via email. So with that, stay safe, everyone, and we'll see you next time.
Thank you, everyone, and thank you,
Thank you,
Sian and
everyone.
Vision. Take care.
Bye.